Good morning, everyone. My name is Yang Priman. Today, I will be presenting the topic of effects of performance-based assessment on achievement and attitudes among low proficiency chemistry students in private schools. Table of content include introduction, literature review, methodology, results and discussion, conclusion, implication, and recommendation. Introduction. Chemistry study involves the properties, composition, structure, and energy change of elements and compounds. Students often find chemistry irrelevant due to the lack of practical application in conventional assessment. Conventional assessment focus on rote memorization rather than practical understanding, leading to disengagement. School-based assessment in Malaysia, implemented since 2012, emphasize performance on specific learning objectives. Performance-based assessment focus on application and practical context, aligning with curriculum goals. Benefits of PBA include the enhanced engagement and achievement in chemistry, especially for low proficiency students. Private school chemistry curriculum designed to build a strong foundation in chemical principles and practical skills, preparing students for the UEC exam. Challenges with conventional assessment is that low proficiency students in private schools face high dropout rates and low test scores. Impact of positive attitudes. Positive attitudes towards PBA can improve student engagement and achievement in chemistry. Importance of assessment practice is that iterating assessment methods is crucial for improving low proficiency students' attitudes and achievement in chemistry. Research questions. First, what is the effect of performance-based assessment towards low proficiency students' achievement in chemistry? Second, what are the low proficiency students' attitudes towards performance-based assessment in chemistry? Literature review. Assessment as a bridge between teaching and learning. Assessment role. Formative assessment guides real-time learning, support continuous improvement. Summative assessment evaluate learning at the end of a period. Current practice in Malaysia, private school emphasize summative assessment. AFL is underutilized. PBA is a form of AFL effective in improving low proficiency students' chemistry performance. It focuses on practical application and real-world problem solving. It enhances skill development, aligns with real-world standards. Conclusion is that shifting to formative assessment like PBA can improve student outcome and engagement in chemistry. Types of PBA. Product-oriented assessment evaluate final outcomes of product like reports and video. It focuses on accuracy, completeness, and quality of the results. Performance-oriented assessment assess practical skill application under teacher supervision. It includes activities like oral report, demonstration, and lab work. Process-oriented assessment examines students' thinking, reasoning, and methodology. It focuses on the scientific process, including hypothesis formulation and data interpretation. Challenges in implementing PBA. Increased complexity. It requires assessing multiple aspects of students' ability within limited time. Extensive time is needed for preparation, performance, and evaluation. Lack of training lead to inefficient assessment and stress for teachers. Concern about fairness and consistency in grading compared to conventional tests. Increased pressure and anxiety among students, especially with the public speaking and demonstration. Feedback and content mastery is less structured and it focuses on skill over content mastery. Students struggle with the practical demonstration of knowledge required by PBA. Difference between PBA and conventional assessment. Nature of assessment of PBA focus on practical application, real-world scenario, and demonstration of skill. Conventional assessment focus on factual knowledge, understanding of theory, and content mastery. Evaluation method for PBA include tasks such as project, presentation, portfolio, experiment, or simulations. Conventional assessment is more structured and standardized with predetermined answers and grading criteria for objective evaluation. Performance-based assessment required a lot of time-consuming, and conventional assessment less time-consuming as students prepare by studying specific material or content. Evaluation style PBS is subjective judgment because of no clear-cut right or wrong answer. Conventional assessment, perception of objectivity in grading due to the use of predetermined answers or clear-cut criteria for assessment. Benefits of PBA in chemistry. Real-world application. It provides hands-on experience that simulate real-world scenario, and it also encourages deeper comprehension of interconnected chemical concepts. It develops practical skills because it involves the handling equipment, measuring and analyzing substance in laboratory setting. It builds confidence and essential laboratory skill for future research or professional endeavors. PBS shift focus from rote memorization to understanding and application because it involves tasks such as designing experiment, interpreting data, and drawing conclusion. It aligns with modern educational principles, emphasizing deeper learning and analytical skills. Low proficiency students in chemistry subject. Definition is that failure to attain fundamental skill in chemistry. Contributing factors include limited prior exposure to scientific concept, ineffective teaching method, language barrier. Challenges faced is that students difficult to apply concept to real-world scenario. Students have low confidence, leading to disengagement and reluctance to participate. Effective strategies include personalized instruction and targeted imitation, hands-on activities and ample practice opportunities, active learning and small group activities. Cognitive constructionism learning theory in chemistry education. Active knowledge construction. PBA promote active engagement and application of knowledge in real-world chemistry problem. PBA tasks connect familiar concept with new scenario. PBA provides structured guidance, rubric, and peer feedback to help students tackle complex chemistry tasks. Scaffolding enables systematic problem solving and support higher cognitive abilities. PBA tasks simulate real-world chemistry problems, enhancing relevance and understanding. Application of theoretical knowledge to real-life situations fosters deeper learning. PBA encourages reflection, self-assessment, and planning strategies. It promotes monitoring and refinement of learning approach, improving comprehension of chemistry concept. Attitude of low proficiency students towards PBA in chemistry. Low proficiency students struggle with assessment focused on memorization rather than practical application. PBA shift focus towards real-world skills and knowledge application. Past negative experience with assessment and feelings of inadequacy can lead to apprehension or resistance towards PBA. Unfamiliarity with PBA and uncertainty about evaluation method may affect attitudes negatively. It is important to give a clear guideline, practice, opportunity, and feedback are essential to alleviate anxiety and build confidence. Scaffolded support through rubrics, peer feedback, and teacher guidance help students approach PBA tasks effectively. Methodology. First is participant selection. Participant is divided into control group and also treatment group. After that, both groups undergo pre-test phase. Control group undergo the traditional method without PBA, but treatment group undergo the intervention phase. After that, both groups undergo post-test phase, data collection, data analysis, interpretation, and conclusion. Research design. Quantitative research, quasi-experimental with pre-test and post-test, control and treatment group. Setting. Conducted in natural classrooms environment across 2 private schools in Johor Bahru, Malaysia. Participants include 68 low proficiency chemistry students, 34 in each group. Formal consent obtained from school, students, and teacher. Pilot study is conducted to get the feedback from a similar school, refine the research methodology. Instruments include achievement test, assess understanding of water electrolysis from 2 topics with reliability KR20 with 0.614, combined alpha 0.775. Attitude questionnaire. Assess attitudes towards various assessments, tests, presentation, and lab work with high reliability combined alpha equal to 0.862. Sampling method include the purposive sampling based on the final year achievement test. Instructional method, control group, traditional textbook based instruction. Treatment group, PBA, including presentation, lab work, report writing, 4-week duration. Data analysis, SPSS version 27, used for independent sample t-test, medium mode calculation, and Spearman correlation test. Findings, insight into PBA's effectiveness in enhancing achievement and attitudes among low proficiency students in chemistry. Data analysis, this is the conclusion of data analysis. Results and discussion. Effects of PBA towards low proficiency students' achievement in chemistry. Control group have a minimum score of 2, maximum score of 18. Treatment group have a minimum score of 13.5, maximum score of 34.5. Inferential statistic of post-test results shows that a statistically significant difference between the post-test mean score of the experiment group and the control group. PBA provide ample opportunity for teachers to have a guided discussion in the treatment group classroom. This discussion fosters numerous ideas, consequently enriching students' comprehension of the pertinent problem. The utilization of PBA helps to engage students towards their lesson, It facilitated the systematic problem-solving process, consequently resulting in an augmentation in students' interest in chemistry learning. This outcome validates the finding of Utami in their investigation of the impact of PBA within classroom setting. Their research revealed that students who execute PBA in class exhibit more robust problem-solving abilities compared to control groups. Descriptive statistics between pre-test and post-test. Control group have a minimum difference of -3.5, maximum difference of 7. Treatment group have a minimum difference of 7 and maximum difference of 23.5. Students' attitudes towards PBA. The data indicate a clear preference among students for interactive and practical assessment methods such as presentation and lab work over traditional methods like tests and written reports. This finding emphasized the importance of incorporating valid and engaging assessment strategies in chemistry education to better cater to students' ability and preference. The results indicate a clear preference among students for traditional and practical assessment methods such as tests and lab work over presentation and report. These insights suggest that students feel more confident and secure with this established form of assessment. While tests and lab work grading are widely endorsed by students as beneficial for learning chemistry, presentation and reports show more mixed perception. While test, presentation, and lab work are generally perceived as fair form of assessment by students, report present challenges in maintaining perceived fairness due to potential subjective bias in evaluation. These findings underscore the importance of transparency, consistency, and clear criteria in PBA to enhance perception of fairness among students. The data underscore varying level of understanding across different types of assessment, with tests and lab work generally perceived as clearer in terms of assessment criteria compared to presentation and report. Varying perception among students regarding the time consumption associated with different types of assessment in chemistry education. Tests and presentation are generally seen as more time-consuming, whereas lab work are more balanced. Reports stand out as particularly time-intensive. Findings highlight that while tests and lab work are widely accepted as effective measure of proficiency in chemistry, presentation receive mixed perception and report are viewed less favorably. Students show robust support for using tests and lab work as grading components in chemistry education, reflecting confidence in their effectiveness and fairness. Presentation and report, while generally accepted, receive more mixed perception, indicating potential areas for educators to consider when implementing PBA to ensure alignment with student preference and equitable assessment practice. While tests and presentation are widely perceived as effective motivators for students to invest more effort in learning chemistry, lab work also play a positive motivational role despite some mixed perception. Reports, however, are viewed less favorably in terms of motivating students, potentially indicating a need for educators to explore alternative methods to enhance engagement and motivation in this area of assessment. A strong positive correlation was found between performance in test and presentation. A significant positive correlation was observed between test score and lab work. The correlation between test score and report was weak and not statistically significant. There was a statistically significant positive correlation between presentation skill and lab work performance. Conversely, the correlation between presentation and report was very weak and non-significant. A significant positive correlation was found between lab work and report score. Conclusion, implication, and recommendation. Conclusion: a significant improvement in chemistry achievement for students who engaged in PBA compared to those who did not. A strong positive correlation between test and presentation, test and lab work. Weak or non-significant correlation between test and report, presentation and report. Statistically significant positive correlation between presentation and lab work and report. Implication: educators should adopt and extend PBA to all students to enhance conceptual understanding, improve achievement, and tailor assessment strategies based on students' attitude. Researchers should replicate the study, explore different assessment strategies, and focus on measuring attitudes towards PBA to define and expand its application. Private schools should integrate PBA into their curriculum, invest in teacher training, and involve parents to improve student achievement and lead in educational innovation. PBA offers a supportive, engaging, and effective approach to improve low proficiency students' performance, confidence, and long-term interest in chemistry. Recommendation: educators should incorporate PBA into chemistry lessons with activities tailored to student needs, while implementing continuous monitoring and evaluation to refine assessment practice. Additional support such as tutoring and extra resources should be provided to help low proficiency students excel in PBA tasks. Future research should expand data collection method and participant diversity to gain deeper insight into PBA effectiveness across various contexts. Studies should explore the impact of contextual factors like school culture and policy on PBA implementation and outcomes. Thank you.